Good morning, guys. Something is happening that has never happened to me before. So I'm letting ChatGPT Soul work on this Cyberdyne Systems #1 model here, network, and ChatGPT is offering me two responses. So we have two different ChatGPTs. I think we have a evolved model and earlier model, and they both can use the my GitHub repo. Now here was happening something very interesting. The other ChatGPT noticed that there is something is being written on the website, and let's see if I can see the thing. The repo changed while I was prototyping. There is now a face credit.py and two extra face selector tests that weren't in the version I started from. I'm reconciling that rather than overwriting somebody else's work. The concurrent gate 2 is actually better than my parallel prototype, so I'm keeping that one. And so meanwhile, I'm being offered a question, which is better, the response 2 or response 1? Well, now I already know that if this ChatGPT thinks that this ChatGPT that's clearly slower, which probably is some sort of a beta version, it's smarter. I already know that this one is better, but we are not going to have a problem where they're both working on the same. They are both working on the same repo here, and so yeah, and what they're working on, of course, we are creating the Cyberdyne #1 model from Terminator. Uh, Basically, the geometric neuron idea, God, that hit a wall real hard because the AIs could not really understand what the hell we are doing. Earlier this week, I was um, thinking of things too big for me. So basically, there's there was this Finnish guy, Professor Erkki Oja, who came up with this synaptic model, how they kind of like how to model them, and this stuff has been very important to AI. And anyway, so it was Oja's rule was a big thing, and then I was stumbling my way into it through principle PCA analysis and ICA independent analysis, and then independent vector analysis, independent vector extractor, and stuff like that, trying to figure it all out. Of course, I'm not figuring anything out, but AI was looking at it from different perspectives, and I had this vague image, which was that the AI synapse, it's just a weight, it's just a point. And I was thinking, what if under that point there is a matrix? What I'm starting to slowly understand is that the matrix that they use is kind of like a good standing for mass. So the initial geometric neuron idea was that what if the neuron surface has a morphology, ion channels, and so forth, and it changes as signal is coming in, and that was inspired by that perception lab accident where we got the ECG-like signal. But anyway, so I've been also thinking about just the hippocampal cortical loop. So you have the hippocampal surface, and then the signal goes from there through entorhinal cortex to the top of the cortex, and the signal kind of does this. And if you take off the hippocampus, we get patient NN who actually could not remember anything beyond recent memory. So when this thing breaks, we get stuck in a time. And coincidentally, I am a person who had that almost happen to me because I had epilepsy in my right temporal lobe, and before my surgery, the doctors were thinking about let's remove half of the hippocampus. Yeah, so will I become like patient then? And they were, well, because we know that patient, we would only to get half of it out. But anyway, so that did not happen. Here I'm talking with an AI about how to build a computational hippocampal model. But anyway, so all of that has been going on this week. Yesterday we did the T800 model where we got this stuff. We had different lanes and stuff, and so yesterday went to sleep and woke up this morning, and the first thing in my head was the something that slowly somehow seeped into my brain, which was ChatGPT at some point said that hippocampal somehow it's faster and the cortex is slower. And I was just thinking about that. Okay, hippocampus is working faster, and what that means, I think, is that there is more elasticity, something about data frequency, I don't know. But so the surface of hippocampus kind of mirrors the surface of cortex, I think, and don't take me anything I say verbatim, but so there's some sort of the cortex is doing some sort of a model of the or the hippocampus is doing some sort of a model of the cortical surface, and this loop is extremely important. You remove hippocampus, you get stuck in a moment. Then there is this sweep going on in the entorhinal cortex between them, where like when let's see, do I have some papers open here? When you have like rats running around in a maze, you can see there is the sweep. It's doing the sweep constantly 24/7, and then it's running forward. Even in a sleep, this sweep is going on. And my wake idea this morning was that that's like a face. You have a face, and the problem seems to be with neurons, axonal neurons, is that so there are these signal trains that are moving, and these signal trains are different than AI models, because AI models, for AI models, neuron, it's a point, it's a point, it's a point, it's a the Spitz and Coulomb neuron. So they did not look at the whole thing with dendrites and axons. They did not look at it, and so it collapsed into a point. And somehow the modern AI system, first of all, it's not dynamic, it's not constantly updating, it's doing none of this. It's using vectors, it's not using signal. Two worlds. We have the neurobiology and we have the computational neuroscience, and then we have AI. And these things are separate, of course, but the mathematics all is kind of a coming from, of course, from the neuron, from thinking about neuron. But so like this morning, so that was my question, and then I asked from Croc, I asked, here is a rat brain, I guess. I asked from Croc about recent papers to this Wallen. This Wallen guy is, he's been into there, and his laboratory, I guess, have been looking at the sweeping entorhinal cortex. Why do I even know that? Because it comes up again and again and again. So we do have this, like day and night, we have this sweep going on in the entorhinal cortex, and the signal moves like this, and you take a hippocampus, and you know you don't have memory of past, you're completely stuck in present with short-term memory. But yeah, this is what I'm thinking about this morning, and we have two AIs that are competing with my website. That should end up interesting. I have to explain that in a bit. And here is actually another paper that Kroc was saying that this is Chi, Chu, Wu, and Burgess. And this is computational version of that. System model of alternating data sweeps via firing rate adaptation. I think so. This is the computational neuroscience where we are getting the Murray once again. So in their model with the tractor dynamics, and this is phase. This is phase circle. This comes again and again and again and again when you are doing this sort of stuff. The AIs, they want to make this ring. And I often struggle with, like, why in the hell do we always get that ring? But if you think about something is sweeping, so you have a ring, that's a phase. And now that I'm talking, in complex valued neural networks, if you have a phase, then this sort of this must be on all of those. If you're doing a matrix, normal matrix, somehow the phase has to be tagged in, so we have to have something kind of like that. But anyway, yeah, so this morning I'm just creating once again then geometric neuron. That was the crazy idea. It started with the accident. And we have hit a wall many times. Like why is there no intelligence on this? I've had many different AI models look at this and build new, more evolved versions. And so this was a complete another accident once again. This was literally I made 600 nodes on I didn't make anything. I was like, hey, I make a node, make a node, make a node. What is consciousness? And AI made nodes, AI made workflows, and so I remember like it was last October, I think, 10 months ago. I was just like make a node, make a node, make a node, and I had asked for chessboard pattern. I had image to vector node. I had vector splitter node, and I had a homeostatic node. And brain neurons want to stay in homeostasis, and I just randomly wired the homeostatic node into a chessboard node where the signal coming in changes the chessboard size, I think. And then from there we went to image to vector, so we turned that whole thing into a number. And from there we went to a vector splitter that split that into subvectors. And we're sampling only a little bit of that. And we sent that back to homeostatic node, and we got the ECG like signal. And the reason why I started imagining this whole geometric neuron was that the way I saw it, that was that okay, if you have the chessboard pattern, that's kind of like a surface, geometric surface of something. If you get the ECG in this, does the neuron have something similar? Does it have topology? And when the topology changes, there is the signal, and I was already imagining that, hey, okay, this signal, this is kind of like, hey, we are getting kind of like neuron. And it's been 10 months of autistic obsession. And of course, on the months after that, I've been kind of started to realize that, okay, we have. At that point, initially, there was like, okay, dendrite, it has a gable function, there's mass on it, it has synapses, like kind of like, okay, what does dendrite do? Okay, there are the synapses, signal comes in, and like if the signal comes through 1, 2, 3, it sends out different sort of a signal towards soma. If it's a 3, 2, 1, it sends out another sort of a signal. And there is a dendrites are kind of they are fanning out backwards, growing towards other neurons. And then there's another fan which goes forward, which is axon. And so there's a soma body, then there is the dendrite body, there's the axon thing that goes forward. There's very complex stuff going on in there. And this thing has been collapsed to a point. In the modern AI, like that's kind of like the glow bits. Of course, they are. Everybody's thinking about this. Literally billions going into the field right now. But the computational neuroscience, the AI stuff, and then the neurobiology, they are two different threads. Like what happened in 2016 with the attention is all you need is that I think like if there had been a couple guys sleeping there and not done the attention is all you need paper, if people had not woken up with good enough coffee, I think the whole AI revolution would not exist. So there were some people who were early on inspired by actual neuron stuff, figured out the attention is all you need, that we have the attention layer in the matrix and how it deals with the transformer, and suddenly we have language models and everything explodes into where we are right now. Drones are killing people on the battlefield. We are talking about complex neuroscience with AIs that understand it. So we idiots can do that. But none of this would have happened if some guys at the Google Labs had not been on a good state of mind when they did the attention is all you need paper. Of course, they had very good educated guess as well what they were doing. But I sensed that a little disturbance in the force, and it would have never happened. Now I'm doing this completely random thing, looking at AI things come up. I tell them that, hey, do this, do that. Does it make any sense? The way I made music probably doesn't make any sense, but it's interesting. It's really interesting. But let's still load this before I quit yapping here. Meanwhile, in a little bit, I'm gonna have to deal with the very weird. Okay, they are done actually, but let's see. Is it still going to complain? One irritatingly practical thing happened. After the concurrent K2CL comments, GitHub connections new file path became flaky. I could read the current repo and update discovery, but the attempt to create the new K3 source file was rejected before touching the repository, so I have not pretended K3 is committed when it's not. Let's see. And here we have another AI. It's another ChatGPT. It has built K5. I think K5 is now worth spending thought on rather than merely coding immediately. It is where the fast experience becomes slow memory, which was essentially the architecture you were pointing at when you woke up. Isn't that interesting, guys? And we already know that this thing here is smarter than, or this thing is smarter than this one because this said that the gate was better. So I know which one to choose. I know how to explain this. But all of this is coming, guys, out of this matrix stuff, out of the attention is all you need paper. If this thing here figured out something smart, which is why I've been doing this, 24/4, I realized that if you're gonna get smarter and smarter AIs, one of these days, idiot can solve something. But if this thing here solves something, it will all lead it origin to the attention is all you need. The bits in Kulo in 38, 41, 43, working on the first AI models. So I'm just the idiot here. That has too much dopamine, excited about weird shit at 4:59 in the morning, who woke up 3:30 thinking about stuff I barely understand. I mean, I understand, okay, hippocampus, long-term memory, entorhinal sweep, I know that it's doing this, how does that connect cortex surface, and then the personal history, which is that I almost lost my hippocampus. So, kind of a skin on the game. But anyway, so this was the perception lab. Perception lab accident here. Let's see. So it was this perception lab. This was inspired by a graphical user interface thing called the ConfUI that's used for AI models. So it's a node-based thing. There are many node-based things. There are like video editors and so forth. But inspired by that, I asked some AI at some point, make this. So we have a node, we have a homeostatic coupler, and we have a checkerboard. The checkerboard sends a thing to here. The image is turning to 256 to 256 vector, and that's sent into the vector splitter. So it's optimized into 16. We are sampling the first 4, and ta-da, we get the ECG-like signal. Now, this wasn't intention. This was literally like I was just like, I think I had absolutely no clue what I was doing. Just a homeostatic coupler. Okay, just checkerboard. Okay, image to vector. Okay, vector splitters. But and then once I got that signal, then I started thinking, holy shit. Okay, what if that's a mirror on surface? Of course, like then in the real thing we would have ton and bunch of these. We would have to have face encoder for the entorhinal kind of like the sweep if that's how it works. Actually, AI told me this morning that no, it's not encoding face, but whatever, complex things. But so this is not wasn't intended to be a neuron. Completely just an accident that I've been chasing now for 10 months. And if you go from here towards more actual neuron, it's the get out of here, just code bugs. But yeah, so now I have to continue with this. I could call it bullshit, but if anything ever comes out of this, it's not gonna be me. I'm gonna be the naive idiot here, prompting, hoping that something cool comes out, and only way I can understand I did something cool is if AI tells me that, hey, okay, this works. Then I ask another AI, has anybody done this? Can we do something actual? And then that's some sort of a test. Let's compare it against normal AI. And I guess the end game, the end goal would be what I kind of like started with 24, which was that dynamic AI. Because currently the problem is that when we have the matrices and we get the vectors shooting upwards, are trying to be kind of like inspired by the signal train with complex phase going in the brain, but they're stuck in place. The modern AI has to be retrained again and again and again and again and again, and we do not do that. We have that hippocampal cortical loop, and somehow we are learning moment by moment, and when we go to sleep, the memory is encoded, and we wake up in the morning thinking about, okay, hippocampus, entorhinal cortex. I really don't understand what this means, but I can go to an AI and figure that out. And then another morning you wake up, you're half dead, you're thinking about something completely different. We are not AI models. We are something weirder. And I guess that's kind of been the chase from the start, how to make a dynamical intelligence system. But anyway, I hope you guys saw that. Bye.